but I want you to look at the model itself and think about what section would make the most sense. I think when we're talking about shaping the space of the interior, I'm definitely going to want to cut a section in this direction, looking into that interior. Before, when I was focused on the stair, I wanted a section in this direction, but I didn't necessarily want it at 90 degrees. I really wanted that section cut, the clipping plane, to cut perpendicular to the stair so that I could see the stair spanning between two floors. So it was more important to see the stair as a clean object in that case and see a little bit of a skewed view, but I don't know which is the 90-degree angle when you're looking at a strange figure, so it's probably okay. So let's go ahead and create a couple of clipping planes in the other direction. I do want you to use the same kind of logic though in positioning your clipping planes. When I'm looking at this and I'm thinking about those kind of operations that I want to apply, I'm thinking probably it's going to be in this main space where I'm looking at these sectional conditions from Lewis-Suramaki-Lewis. So I'm going to want for my clipping plane probably to cut this way and look into the model. And right now this is cutting in a, in a kind of odd angle. So I'm going to want to, for the second clipping plane, reset my construction plane so that I can easily create a section which has a geometric relationship to a model part. So I'm going to begin with my C-plane. I'm going to relocate the origin, and I'm going to relocate it to an object. In this case, I'm going to select the wall, and then I'm going to draw the clipping plane relative to the new construction plane. That way, the new clipping plane will be parallel to the wall. We can see that I have a nice clean clipping plane that aligns with that wall. So this again is going to have a better relationship to the object that I'm cutting through. I'll draw the second clipping plane, and I'm going to make this one parallel to the 9-square frame, which will give me a good cross-sectional view of the interior of my model. So you'll see that this clipping plane has basically been constructed in the opposite direction. So I am going to rotate my clipping plane 180 degrees so that it will orient the other direction. Okay, and now I'm going to want to move it. Okay, because I've gotten used to kind of working in this direction. Although it would be really nice to see my stairs in the distance in my exercise. So maybe I'll undo that. When we move this clipping plane through the object, we're really going to get a kind of much more intelligible section. So you can see when we're thinking about the Lewis-Suramaki-Lewis language that we have a pretty static section right now. All of our sections are stacked, they're uniform in dimension. So I am going to ask you guys within this exercise to look at the different sectional types and use some of your Rhino tools to begin to operate on these floor planes so that they become more dynamic. And this is where I want you to go to also look at kind of what's complete or incomplete. If we were to call this a building, what are we missing? I'm going to hide this plane that I'm not happy with anyway. And now I want to look. So we know that I intentionally left a section of wall open. I'm going to want a transparent wall in that area. But I also don't really, there's some ambiguity right now about what is a roof and what is a floor. So right now I've treated this as a floor. So I'm going to say this is an interior floor and I'm missing a roof. And so we're going to talk about a couple different sort of ideas about the roof and how to cap that. But really in terms of this sort of Lewis-Suramaki-Lewis, we're going to operate on this set of floors to look at some of those sectional conditions.